So the Interreg 5A funded Source to Tap project has been restoring an area of peatland which was previously planted with conifers and trialling different restoration methods to find out which is the most effective. Approximately 68% of the island of Ireland's drinking water comes from peatland, whilst up to 75% of its soil carbon is in the form of peat. In catchments such as the Arun, however, when the peatland dries out, it can release carbon dioxide into the atmosphere and earthy coloured carbon compounds into the water, and these compounds can really cause challenges for water treatment. Restoration work aims to re-wet the peatland and reverse these processes, thereby improving water quality and enhancing an important globally rare habitat. The 32.9 hectare test site here in Tullycherry Forest is next to the internationally designated conservation site of Pedigo Plateau, and this was planted by Forest Service NI in the 1960s. The peat was prepared for planting using double moldboard ploughing. This leaves a characteristic ridge and furrow pattern which needs to be levelled out to ensure that the water table is able to recover sufficiently. If you have a high water table, the critical sphagnum mosses can recolonise. Their spongy structure can retain moisture and prevent the bog from drying out. And it's partially decomposed sphagnum that eventually makes up a large proportion of the peat material.
The pilot aimed to look at how well a restoration technique called cell bonding was able to help the water table recover when compared with the traditional method of drain blocking using peat dams. The aerial view shows how the site was split into 3 sections for different methods of restoration. This centre section of 8.2 hectares was the flattest, and so was chosen as the intensive restoration area to trial the cell bonding technique. This area to the southwest was of similar size and topography, so was used as a control area aimed to replicate what the Forest Service would do when leaving a site unplanted for restoration. Minimal restoration was carried out in this control area. Across the remaining area, which covered around 12 hectares, all forested drains were blocked every 12 metres or 30 centimetre fall on ground level. Accurate height information is required to ensure an even recovery of the water table, so surveys were undertaken using drone and handheld GPS units.
Cell bonding is a construction of watertight cells made from low peat walls. These walls are around 40 to 50 centimetres high and are constructed at a 90-degree angle to the slope, with bunds approximately 20 metres apart or less on steeper ground. Finger bunds are then constructed at 20 to 40 metre intervals in line with the slope. These join the parallel bunds to prevent lateral erosion and wave action. Firstly, a short section of trench is dug through the oxidised top layer of peat and any stumps which were in the way removed. This step's important as oxidised peat and rotting roots form pathways for water to escape. The digger then constructs the bunds from saturated peat dug from a borrow pit within the cell. The saturated peat is watertight and prevents movement of water. The borrow pits are then filled with brash and stumps to prevent deep holes which could be dangerous to wildlife. Diggers use existing brash mats to travel across the site and construct the bunds.
The contractor used peat dams to block drains and brash mats, as well as building a cell bund wall for 500 metres along the southern boundary of this control area. These measures were intended to mimic what Forest Service would do to allow an area to restore. The remaining area of harvested land was restored using a popular method of peatland restoration, using peat dams. This involves blocking each drain at 12 metre intervals or placing one drain for every 30 centimetre drop in ground level. Dams were constructed using a digger, which dug a 50 centimetre notch into the sides and base of the drain. Saturated peat from below and bog surface was then compressed into the drain to form a peat dam. The water table was monitored using piezometers and results were compared between the different treatments.
By restoring and protecting peatland using techniques trialled at Tullycherry, it's clear that nature-based solutions can play a critical role in delivering key societal outcomes, key economic outcomes and key environmental outcomes. The ecosystem services that the site provides, it's a globally rare habitat and it gives us improved drinking water quality through raw water, improved biodiversity, and it really helps us to tackle climate change in the long term. Restored peatland also enables bogland to act as a filter for water, naturally improving the quality of any water leaving the site and entering the treatment works. Tully Cherry is part of a long-term strategy. Over the next 10 years, the Source to Tap pilot site and other sites that we're working on will continue to recover. They'll be thriving with insects and bird life, and they will store carbon, which will help us to combat climate change for centuries to come.